I would like to use this medium to quickly revise scaling, okay, because we are to find bearing and distance. Sometimes the distance has to be given to us in kilometers, even meter. Even if it is meters, can we draw, let's say 10 meters? Let me just say 10 meters. Can we draw 10 meters on our paper? Not to talk of kilometers, like 1 kilometer. But we might be asked to calculate bearing from one place to another, okay, whereby the distance will be given to us. Let's distance of 10 kilometers, okay. If this angle, we can draw it. We can draw any angle, as far as complete angle is 360-degree, we can represent any angle on paper. But some distances, okay, we can't represent them, okay. How can we represent 10,000 kilometers on our paper before we calculate the bearing required? Okay, that is why we are going to look at scale, how to choose scale, or how to make use of scaling. Okay, we make use of scaling in drawing, construction, even in our map. All right, the formula I'm going to give you is what we are going to use throughout. Okay, formula for scale is this: over corresponding actual length. Okay, this is the formula we are going to use to calculate scale. Okay, remember, if you have congruent shapes like triangle or rectangle, we can easily get the scale. Let's say you have this rectangle, you have another rectangle, corresponding. If they are congruent, let's say here is 3 centimeter and here is 9 centimeter, okay, and here is 6 centimeter. So if this is the case, and the length are congruent, you can easily say the scale equal 3/9. 3 here 1, 3 here 3. So we can use this scale. This scale can help us to reduce the rectangle or to enlarge the rectangle. Like here, the length is 3, here the length is 9. Okay, the breadth here is 6. We don't know. For the fact that the scale is 1/3, okay, we can easily multiply 1/3 by this to get this. All right, so that is 1/3 times the corresponding side. 1/3 times 6/1, 3 here 1, 3 here 2. Okay, that's going to be 2 centimeter. You see, because of this scale we have used, so here automatically will be 2 centimeter. All right, I've given us the formula for scale. Scale is length on drawing over actual length. Okay, all right, then we are going to use it to complete this table. Let's assume the scale is 1 centimeter to 50 meter. The scale used on a particular drawing, whether house, map or not. The length on drawing, we are looking for the length on drawing. The actual length is 250 meter and we cannot draw that on paper. So how do we get the length on drawing? Let us apply the formula. The scale here is 1 centimeter to 50 meter. Always make it in fraction. Okay, the scale of 2 centimeter to 100 meters. So in this case, just divide, just make it fraction. That is 2 centimeter over 100 meter. Just take it as your scale. Okay, then you proceed. All right, so here I'm trying to find the length on drawing. Okay, the scale is 1 centimeter to 50 meter. What is the length on drawing if the actual length is 250? Okay, this is the scale. 1 centimeter to 50 meters, okay, equal to length on drawing is the unknown. All right, I'm going to use x for the length on drawing over the actual length. The actual length here is 250, right? Okay, 250 what? Don't forget, 250 meters. All right, so let us continue from here. 1 centimeter to 50 meters is the scale. Here we can, this meter can cancel this meter, of course, this m. But if you're not sure, let us just cross multiply. Okay, if that is going to confuse you, but I'm telling you this meter can cancel this meter. Okay, but let us just cross multiply if you're not sure. Then x times 50 meter, I cross multiply, is equal to 1 centimeter by 250 meter, right? We are looking for x. We divide both sides by 50 meter. Divide both sides by 50 meter so that x can stand 50 meter. All right. So this 50 meter cancel this 50 meter. You can see x is standing. So okay, m cancel m. 0 cancel 0. 5 in 25. 5 here 1. 5 here 5. 5 times 1 centimeter, that is 5 centimeter. So x equal 5 centimeter. Remember, the length on drawing that we use x to represent is 5 centimeter. So x is 5 centimeter, which means the length on drawing is 5 centimeter. All right. So for this question, the length on drawing is 5 centimeter, as far as 1 centimeter represent 50 meter. Okay, I hope it is clear. So let us look at this as well. Okay, I believe you have written the formula somewhere. Then we are to the scale here is 1 centimeter to represent 10 meters, right? What is the length on drawing if the actual length is 90 meter? Okay, scale, length on drawing of actual length. Okay, we have done this, right? Now we're looking at it. So 1 centimeter to represent 10 meter, and we know the scale. This is the scale. Scale is 1 centimeter. Just write the unit over 10 meter. In fact, the unit is very important. Okay, 1 centimeter over 10 meter. That is the scale. Okay, so equal to length on drawing. We don't know, so let us use x. Okay, what of the actual length over actual length? The actual length here is 90 meter, right? 90 meter. Okay, let us cross multiply. Let us cross multiply. Like I said, this same denominator can cancel each other, but if we cross multiply, that means x times 10 equal 1 centimeter multiplied by 90 meter, right? Okay, since we are looking for x, we divide both sides by 10 meter straight. Just divide both sides by 10 meter. All right, so that meter cancel meter. 10 here 1, 10 here 9. 9 times 1, 9 centimeter. So x equal 9 centimeter. Remember, x represent the length on drawing. So this is 9 centimeter. Look at this third one. We are done with this. The third one, 1 centimeter to represent 20 meter, right? Okay, 1 centimeter to represent 20 meter. That is 1 cm to represent 20 meter. So length on drawing is given to us, which is 10 centimeter. Okay, length on drawing is given to us. The actual length we don't know. Okay, you can see it's the same thing. So still cross multiply. X times 1 centimeter, that is x times 1 centimeter equal 10 centimeter times 20 meter. All right, 20 meter. Now divide both sides by 1 centimeter. Since we are looking for x, divide both sides 1, because the coefficient here is 1 centimeter. So just divide both sides by 1 centimeter. Okay, this just cancel this, right? So what matters here is the centimeter that will cancel the centimeter, right? This centimeter cancel the centimeter. We are left with 10. Okay, 10 times 20, that is what? 200 meters. Okay, so x here, x equal 200 meters, and that is the length, the actual length. That is the actual length. You can see 200 meter. The third one, the scale is 2 centimeter to 1 kilometer, as you can see. Okay, let me solve it here. The scale is 2 centimeter to represent 1 kilometer. That means 2 centimeter to represent 1 kilometer. This is the scale. Okay, then length on drawing is 14.8. Remember, scale is length on drawing over actual length. So length on drawing here is 14.8. Go with this unit. Okay, over actual length unknown. All right, cross multiply as well. Okay, if you cross multiply, x times 2 centimeters is equal to 1 kilometer multiplied by 14.8 centimeter. We are looking for x. All right, the coefficient here is 2 centimeter. We divide through by 2 centimeters. 2 centimeters. Okay, so well, this centimeter cancel this centimeter. You can go like that. Then 2 in 14.8. 2 here 1, 2 here 7.4. Okay, times 1 kilometer. X is equal to 7.4 kilometers. That is the actual length. Okay, 7.4 kilometers. Okay, let us have this question. bearing and distance. A ship sails 20 kilometers from A on a bearing of 042 degrees to point B, and a further 22 kilometers due east to arrive at C. Using a scale of 1 centimeter to represent 5 kilometers, make an accurate diagram showing the location. B. Measure AC and find the actual distance from A to C. Alright. Well, we have the starting point. The starting point is A. Okay. The ship start from here, A. Remember, this A is nothing, but we have to draw the cardinal point to represent the A, and moves on a bearing of 042 degrees. Okay, this is the bearing. The angle here is 42. 042 is taken as 42 degree. And what is the distance? 20 kilometer. The distance is 20 kilometer. All right. To point B. Oh, to point B. This is point B. It moves from here to this point. Okay, the bearing is 42 degree. The distance is 20 kilometer. So at B, it moves due what? East to arrive at C. Okay, and what is the distance from B to C is 22. So 22, the diagram, this is a rough sketch anyway, but the line from here to C should be longer because this is 22. Okay, this is 20, this is going to be 22. Just make sure it is longer even though it is rough sketch. All right, this is point C. Okay, the ship moves from here to this point, then at the bearing of 42 degree 20 kilometer, then the distance is 22 kilometers. Okay, so this is a rough sketch. Of course, we are going to join this. We always make it triangle no matter what. Okay, just make sure it makes triangle. All right, then we are going to make use of our scale here. Remember, this is the drawing, but it's not accurate. It's not drawn to a scale because, of course, from here to here is you cannot draw 20 kilometers on drawing. It's not possible. But the scale given to us is what? 1 centimeter to represent 5 what? 5 kilometer. Okay, that is the scale. 1 centimeter represent 5 kilometers. That is going to be scale. Scale is length on drawing. If I need to find the on drawing, so let me say length on drawing, let me use x. The actual length is 20. Okay, cross multiply. Okay, x times 5 kilometers is equal to 1 centimeters times 20 kilometers. Okay, we are looking for x. Divide both sides by the coefficient, which is 5 kilometer. 5 kilometers. Kilometer cancel kilometer. 5 in 20, 4. 5 here 1, 5 here 4. 4 times 1 centimeter. So the length on drawing is going to be 4 centimeter. So which means by the time we are going to draw this diagram, this length, this 20 kilometer is going to be 4 centimeter on drawing. All right. What of 22 kilometer? So what is going to be the length on drawing? Then the scale. This is still the scale. Okay. Scale is still 1 centimeter to represent 5 kilometers. Then for this 22, the length on drawing, let it be x. Why? Because the actual length is 22 kilometers. All right. So we cross multiply. X times 5 kilometers is equal to 1 centimeter multiplied by 22 kilometers. So again, divide both sides by 5 kilometers. 5 kilometers. Okay. Kilometers cancel kilometer. So we are going to divide 22 by 5. That is 4.4. So okay, x equal 4.4 centimeter. So by the time we draw this, it's going to be 4.4 centimeter on drawing. All right, let us have our sketch. We are going to measure for the angle is 42, so we can measure any angle. We don't need to find scale. 42. Okay, let it be like this. 42 degrees. You can see how I place it. This is 40. This is 40. Okay, let me use pencil for accurate. And this is 40. This is 42. All right. That is my 42. Just forget the length. Okay, or we can just go with the length. The length is 4 centimeter. The length is 4 centimeter. and the bearing is 42. This is 4. Okay, this angle for real is 42 degrees, and this length is 4 centimeter. Okay, then at this point we can draw the cardinal point. So at this point, this is point A, this is point B. Okay, remember this is, let me write it with pencil. This is 4 centimeter. This is point B. Then the ship now move 22 kilometer. Remember that 22 kilometer, we are now using 4.4 centimeter to represent it. Okay, from here to this place is 4.4 centimeter. This is 4.4 centimeter. All right. So this is now point C. Point C. All right. Then let us see the distance from A to C. All right. So AC, this length AC is equal to 7.8 centimeter. 7.8 centimeter. That the ship is now here. So the distance of this ship from here to the starting point, the distance of the ship from the starting point is AC, which is 7.8 centimeter. Remember, it is not 8.5 centimeter. We have to take it to actual length. Don't forget, this 7.8 centimeter is not the true value, because we must take it to actual length. Now it is, this 7.8 is length on drawing. From here to here is 7.8 centimeter, which is what is required in B. So we are going to take it to actual length. Still, don't forget the scale. The scale is 1 centimeter to represent 5 kilometers. So the actual length on drawing is now 7.8 centimeter. So we are looking for the actual length, which is x. Cross multiply. X times 1 centimeter is equal to 7.8 centimeter times 5 kilometers. All right, times 5 kilometers. So divide both sides by 1 centimeter. By 1 centimeter. Okay, this centimeter cancel this centimeter. This centimeter cancel this centimeter. Now we are going to have 7.8 times 5. Okay, that is 39. So x is equal to 7.8 times 5 kilometer. That is equal to 39 kilometer. And this is real. The answer is 39 kilometer. You see, we did not use any instrument, we did not use anything. Just because the scale is given to us, we're able to know the distance between this endpoint and the starting point. Okay, it is 39 kilometers. I hope you understand this lesson.